So the next conic section we want to talk about, we've discussed this briefly already, is the parabola. So we're going to look at parabolas today. And so you've seen parabolas before. Parabolas are the graphs that come from quadratic equations. So you're all familiar with quadratics, y equals ax squared plus bx plus c. And we talked about how we shift these around, how changing a, b, and c shifts the graph in different ways. But the two things that we're going to focus on today are two new terms. And those two terms are the focus of a parabola and the directrix of a parabola. So these are two things that you probably haven't seen before when you're discussing parabolas, but we're going to talk about what they mean. Because there's another way to define a parabola. So a parabola is the graph of a quadratic equation. So it is what you get when you graph something like this. But it's also another way you can define a parabola is the set of points that are equidistant from a focus and a directrix. So a point and a line. And that may sound kind of confusing at first, but what that means is, so we're looking at the set of points equidistant, which means they're the same distance from a focus and directrix. Okay, so what that means is that all of the points on this parabola are the same distance away from the focus of the parabola and the directrix, which is this line underneath the parabola. And so no matter where you are on the graph, and that's what these two sort of illustrations are showing, is if you're at this point right here, you draw a line straight over to the focus. This distance here, this distance right here is the same as the distance from that same point to the directrix. So we drop it straight down, we have a perpendicular line, and so these two distances are the same. So it would be the same no matter where I am, even if I go all the way up here and draw a line from here to the focus. That's not a very straight line, sorry. And then I also drop a line straight down from here, a perpendicular line. So these two distances would also be equal, so equidistant. So this point is equidistant from the focus and from the directrix. So that's an important thing, and we can use that to do some interesting things with parabolas. So I want to talk about sort of real life examples of parabolas. So you might have seen something like, you've probably seen something like this before for sure, on your house or on your neighbor's house. This is a satellite dish. This over here is a radio telescope. So it is essentially the same thing. It's doing the same physical process, but on a much larger scale. And let's talk about why these things work. So these are both examples of essentially 3D parabolas. So the shape of this, if you were to take a cross section of this satellite dish right here, you would see something that looked like a parabola with a focus and a directrix down here. So you could do that. And so let's look at a diagram of that. So that's what we're looking at right here down here. Let's just say that this is a cross section of one of these two big satellite dishes up here. And so what essentially happens is, let's say you've got in the case of both of these, I know this is looking at radio waves. I believe a satellite dish would be looking at radio waves, but I'm not positive, like one on your house. But this is used to do radio astronomy, so things like stars and stuff like that will send off, in addition to light in the visible spectrum, so light that you can see, they also send off radio waves, which you can't see, but is a form of electromagnetic radiation. And so when those waves come in, all of those waves come in, let's assume they come in straight lines, and they hit some point on that big dish up here in this big thing that looks like a parabola, and then they're immediately reflected and sent in the direction of the focus. And so the focus is basically where all of these waves get reflected, and they all end up in the same place, which is the focus. They sort of the satellite dish focuses all of these waves into one single point, and so it basically, instead of having to look at all of these little waves individually, we can look at them all much more clearly. It sort of magnifies them all by making them all look a lot more their signal's a lot stronger right here at the very center. And so you can think about this the same way, sort of, if you imagine this being, this is not a directrix up here, but if you imagine the geometry sort of works the same way, where when something's coming into a parabola, it's reflected, and all of those reflections end up at the same point. That's what the focus is. So that's sort of how we leverage this math to do actual real science and even make everyday things work, like your satellite dish on your house. And so getting back to the math of all this, so in the previous Edpuzzle video, you looked at it was a Khan Academy video on Edpuzzle. You looked at how to find the vertex and the axis of symmetry from the equation of a parabola. So we looked at something called the vertex form of a quadratic, which you probably remember, and that's when you have something like x minus h quantity squared plus k. And so the coordinates of your vertex here, the vertex right here, the coordinates of that are at h comma k. So whatever basically you change the sign on this value inside the parentheses, and then you add k is the y coordinate of the vertex. So the vertex of this parabola would lie at h comma k. And that's easy to read from the vertex form of a parabola. If you're not given the vertex form, if you're given a parabola just in standard form, something like ax squared plus bx plus c, you also learned in that video, and you probably learned before in a previous math class, how to find the vertex. So the vertex, in this case, you can find using the equation negative b over 2a. So that would be the x coordinate of your vertex, and then your y coordinate would be whatever the y coordinate is when you plug in this x value. So in other words, it would be, I guess you could write it as f of negative b over 2a if you wanted to think about it that way. So this is the coordinates of your vertex. If you are given the standard form of the equation, you can still find the x coordinate of the vertex pretty easily. Just do negative b over 2a. And then you plug that value in to find the y value of the vertex. So both of these will get you to the same place, depending on which form of the quadratic equation you're given to begin with. All right, but the other thing that I want to introduce to you is, say you're given an equation like this over here, some standard form of an equation of a parabola or a vertex form, and you're asked to find the focus and the directrix. How are you going to do that? So if we think about the distance between the focus and the vertex of the parabola being p, so we're going to call that distance p right here. And we know that we already said that the definition of a parabola is that all of the points on this parabola are equidistant from the focus and from the directrix. So that means that if we go from the vertex to the focus, that distance is p. Then if we go from the vertex to the directrix straight down, that distance is also p. So these two things have to be the same. That's the definition of what a parabola is and what the focus and the directrix are. So if we say that distance is p, this is just a useful thing that's going to come in handy a lot here, is that p, the distance between either of these 2 points, is equal to 1 over 4a, where a is this a in the standard form of the quadratic. So, and there's a derivation of why that is. I'm not really going to get into that. The important thing for you to remember and be able to do problems in a couple minutes is to know that the distance from the focus to the vertex or from the directrix to the vertex is 1 over 4a. So that means that, let's say if I asked you for the coordinates of the focus, right, if I asked you for the coordinates of the focus of this parabola, right, the focus is going to lie at, it's going to have the same x coordinate as the vertex, right? These are in the same vertical line, so the x coordinate is going to be the same. So that's just going to be negative b over 2a, or we're just going to say h for now. All of those are equivalent, right? H and negative b over 2a are the same thing. And then the y coordinate is going to be whatever the y coordinate of the vertex is plus p. So the y coordinate of the vertex over here was k, so it's going to be k plus p, which is the distance from the vertex to the focus. Okay, so all we did was take the vertex that we had originally and we added p to the y value in order to go from here to up here. And so if you wanted to rewrite this, you could write it as h comma k plus, and we said p was equal to 1 over 4a. So all I'm going to do is substitute that in to get something that we know how to deal with already. So the coordinates of the focus are h comma 1 over 4a. And so remember that this a, we could also think about having an a up here. So in this case, in this form of the equation right here, the a multiplying on the x squared term would be 1, but you could have any number multiplying there. So you can assume that there's always an a in front of this parentheses here. So whatever happens when you FOIL this term out in parentheses here, you're going to get a multiplied by x squared. as your x squared term. So the a you can think about as being the same as the a down here. You can use both of those a's to find what p is when you're looking for the focus or the directrix, which we're going to talk about next. So now let's look at the directrix. So if we wanted to know the equation for the line of the directrix, so the directrix isn't a point, so it's not going to have something comma something. It's not going to be an ordered pair. It's going to be an equation of a line. And since it's a horizontal line, it's going to be in the form of y equals something, right? So this is going to give us a horizontal line, and we want to know what goes here. What y is equal to what? Y is going to be equal to whatever the y coordinate of the vertex was, which we said was k, right? Right over here we said k is the y coordinate of the vertex, and then subtract from that whatever the distance is from the vertex to the directrix, which is p. So we said that was p. So y is equal to k minus p, and so the equation for the directrix, this is the directrix, the equation for that is going to be k, whatever the y value of the vertex was, minus p, which we said was equal to 1 over 4a. So these equations in the boxes right here, especially the red one and the green one for the focus and the directrix, these are the two most important ones for this parabolas unit if you're going to need to find the focus and the directrix. And again, sometimes you might be given the coordinates of a focus and asked to create the graph from that, or asked to write the equation from that. You should be able to work back and forth between these two. And there's going to be a couple practice problems that you're going to do next to sort of solidify that. And that's really the only new stuff we're adding with parabolas here, is talking about what a focus is and what a directrix is, basically a different way of looking at parabolas. So one last thing, let's look at a sideways facing parabola, because we might encounter those as well. And you've seen these before. All we're doing is we're looking at the inverse of a normal parabola in this case. So when we take the inverse, remember all the x's and y's get switched. So the equation for a sideways facing parabola would look like this: x equals y squared instead of y equals x squared. And so if we wanted to write this in vertex form, like we were dealing with earlier, we could write this as x is equal to a times y minus, and this time we're going to have k on the inside of the parentheses, squared, plus h. And so the reason that we flip these, if we were to actually algebraically solve it out, you would see where they come from. I'm not going to take the time to do that right now, but the h and the k, note that they've switched places as well as the x and the y. And so we can still use this to find the coordinates of our focus and our directrix for a sideways parabola. So let's first look at our vertex, which we haven't discussed yet. So the vertex of this parabola is still going to lie at the point h comma k. So we've still got our same vertex at h comma k. Remember, they've switched places, but that's still the coordinates of our vertex. And so remember also that we've still got the distance from our vertex to our directrix, and I know this graph is harder to see, it's still p, and the same thing is true. The distance from the vertex to our focus is also p. So these are still equidistant. That's still the same thing. And so p, remember, is equal to 1 over 4a. So this relationship is still true as well. The distance from the vertex to the focus and from the vertex to the directrix is equal to 1 over 4a. And so let's look at how that affects our focus and our directrix in this case. So if we want to find the coordinates of the focus of this parabola, so the y coordinate of the focus is going to be the same. The axis of symmetry is still is in the horizontal direction now, and so the vertex and the focus are in the same location on the y-axis, but not in the same location on the x-axis. So our y coordinate is going to be the same as it was for the vertex, so that's going to be k. However, our x coordinate is going to be whatever h was plus the distance p, right? Plus p from the vertex to the focus. So we're going to do plus p, and I'm going to go ahead and substitute that in. Instead of p, we're going to have 1 over 4a. So our coordinates for our focus would be h plus 1 over 4a, and then k would be our y coordinate. And then if we want to look at the directrix, we're going to look at a very similar process to before, where now instead of a horizontal line, we're looking at a vertical line. So vertical lines, remember, are x equals something. So we want to know x equals what? Well, again, we're looking at if the x coordinate of the vertex is h by itself, we want to look at h minus the distance from the vertex to the directrix, right? So we want to do h minus p, or in this case, we would look at x equals h minus 1 over 4a. So that is our equation for the directrix. This is our equation for the focus of a sideways facing parabola.